Hello everybody, I'm James, the Unlucky Thief. Today we are going to talk about the imaginary numbers. Speaking of numbers, let's have a quick review about the history of the numbers. At first, people don't know how to describe the number of a type of object, like two sheep. I think at first they just call them sheep. But when the sheep get more and more, just simply calling their name many times become impossible. So we counting stones, nodding notes, and finally we create natural numbers with a zero to become whole numbers. Yep, with 4 operations. And we have negative number to deal with questions such as 1 minus 2. We call integer as a whole. And fractions that deal with questions like 1 divided by 2. We call them rational numbers as a whole. There are some numbers just infinitely continue and not repeat. We call them irrational numbers. And we call all of those real numbers as a whole. But part of the imaginary numbers does not belong to the number line. Like the first 2 creations, imaginary numbers come from the question. Yep, a squared plus 1 equals 0. This means that a must be a negative number. You know that no matter it's positive or no, the square of it must be positive. You can't get a negative from a theorem that only gives you positive. Just like you can't get a pumpkin from a machine that only gives you stone. But wait a second. Although we cannot solve it, but we can simplify it. So, a just equal to square root of -1, the letter I to present it. We have the unit of the imaginary numbers. By the way, the imaginary number is created by
René Descartes.
in 17th century. He named imaginary numbers imaginary number because he thinks that those numbers shouldn't exist. Well, it exists. Let me show you where it is. Let's say the number line is the x-axis, then the imaginary numbers is on the y-axis. To get the unit of the imaginary numbers, we need to rotate the unit of the real numbers, which is 1, 90 degrees anti-clockwise. It's just like creating a circle, but the center of the circle is 0, and the radius of the circle is the distance between 0 to 1, also 0 to -1. So the distance between 0 to I is equal to the distance between 0 to 1. By the way, Gauss renamed imaginary numbers to lateral numbers because it's stand on the y-axis. Unlike the degree of the real numbers, the degree of the imaginary numbers only have 4 possible values. Like I to the power of 1 equals I to the power of 2 equals to -1, I to the power of 3 equals to -I, and I to the power of 4 equals to 1. And let's start over again. I to the power of 5 equals to I to the power of 6 equals to -1, I to the power of 7 equals to -I, blah 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 blah. Here's why. I to the power of 1 is equal to I obviously, and since I is square root of -1, I squared equals to -1. I to the power of 3 equals to -1 times I equals to -I. And I to the power of 4 equals to -I times I, so equals to 1. These 4 values never change because they always times 1. For example, I to the power of 999. 999 divided by 4 equals to 249 with 3 left. So I to the power of 999 equals to -I. This interesting fact does help you have a better understanding how I rotated 90 degrees anti-clockwise from 1, right? Imaginary numbers has been used in system analysis, signal analysis, quantum mechanics, relativity, fluid mechanics, and much more cool stuffs. What a cool and magical imaginary number!